This section will be very similar to the previous section, only we're solving systems of linear equations in 3 variables instead of 2 variables. So recall that the general form for a linear equation in 3 variables is simply ax plus by plus cz equals d. The coefficients, or the numbers a, b, and c, and d can be any real numbers you want, the only restriction being that a, b, and c cannot all be 0, otherwise you just get 0 equals 0. Okay, we'll consider this system of 3 linear equations in 3 variables. All we want to do here is determine if this 3-tuple, -1, -4, 5, is a solution. Remember, this would be the x, that would be the y, and that would be the z. So all we need to do is replace these 3 variable values into the equations and see if we get a true statement. Now remember, if this is a solution of one of the linear equations, that doesn't mean it's a solution to the whole system. It has to satisfy or work in all 3 of these equations. So let's give it a try here. The first equation, replacing x with -1, would be -1 minus 2 times -4, because that's y, plus 3 times 5, that's z, equals 22. Now, we can go ahead and check this right now, because if this is not true, we're done. It's not a solution. Let's go ahead and check. -1 plus 8 would be a 7, right? Plus 15 is 22. Okay, the first equation works. So we'll continue. The second equation says 2 times x, which would be 2 times -1, minus 3 times y, which would be y is a -4, minus z, which is 5, equals 5. So let's check it. -2 plus a 12, -2 plus 12 is 10. 10 minus 5 is 5. So far, so good. One more equation to check. X is a -1, so we have 3 times -1 plus -4 minus 5 times z, which is 5, equals -32. So a -3 and a -4, that's a -7. -7, and this is -25. -7 and -25 is -32. Absolutely. This ordered pair is definitely a solution. The emphasis, whenever you take an ordered 3-tuple like this, it has to satisfy all 3 of the equations in order to be a solution. All right, well, before we dive into how to solve a system of 3 equations in 3 variables, let's just do a little exercise here. Consider this system of 2 equations, and notice it has 3 variables, x, y, and z. We're going to use the addition or elimination method that we already know to produce one new equation in only 2 variables, x and z. In other words, we need to get rid of the y. Produce a new equation that does not contain the variable y. Well, let's see. If we simply add the equations together, that wouldn't take care of it. We wouldn't eliminate the y. We have a 4y here, and we have a -5y here. What would we multiply these equations by to get the coefficients in the y's opposites of each other? So when we add them, they would give us a 0. Well, we could just multiply the top one by 5 and the bottom one by 4. Kind of reverse these numbers almost. We'd have a positive 20y on top, and then multiplying this one by 4, we'd get a negative 20y. So let me make a note that we're going to do times 5 and times 4. All right, so the first equation, when we multiply it by 5, we get 5x, then we get plus 20y minus 50z equals 65. Let me make sure we did that correctly. All the coefficients should be multiplied by 5 now. So the 1 becomes a 5, the 4 becomes a 20, negative 10 becomes negative 50, and 13 becomes 65. Okay, second equation, we'll multiply by 4, giving 8x minus 20y, and then minus 4 times z, and then let's see, 2 times 4 is 8. So we reached our goal. We haven't done it yet, but when I add the two equations together, y will disappear. We'll get an equation in only variables x and z. So this looks like it's 13x minus 54z equals 65 and 8 is 73. That is our new equation that has only two variables. So I'll jump ahead for a minute. Well, let's just look at the recipe. The recipe for solving a system of three equations and three variables is going to use exactly what we did right here. Okay? So here's how we're going to solve a system of three equations and three variables. We're going to reduce the system to two equations and two variables, and then solve using substitution or elimination like we did in the previous section. And then use the solution from one, which gives us the solution to two variables, to back substitute to solve for the third variable, and then check the solution. So again, what we're going to do is something that looks like this twice. We're going to pick two of the equations, two of the three, and do this. And then we'll pick a different two and solve and eliminate the y again. And then we would have two equations in x and z, and then we could just solve it like we did in the previous section. Again, I only have two equations here. We'll have three in the next video. So we will solve our first system of three equations and three variables in the next video.